Let's talk about AVEVA's Open Message Format and how you can use it with Connect Data Services, Edge Data Store, and AVEVA PyServer. It allows a streamlined way of writing data into those platforms. And specifically, a very important thing to note is that it is a specification. It is not an API or SDK or install kit. It simply defines a set of rules for how you can create messages that'll be automatically understood by Edge Data Store, PyServer, and Connect Data Services. So the important thing there is that it does not require you to load any software into a particular platform or run in a certain operating system. If you want to get data into Edge Data Store, PyServer, or Connect Data Services, and you want the most streamlined way of structuring your messages, it can absolutely do that for you. And it gives you amazing platform independence since it doesn't require you to install any software or kits in order to generate your messages. So to get into a little bit more detail, so when we talk about outlining a set of message formatting rules, this includes specifying like keywords and JSON structures that basically tell you if you can format your data and metadata in this format and send it to one of our destinations, we'll accept it, automatically create streams for you, and treat it as if this data was coming from one of AVEVA's own components. If you want to develop custom applications for writing data, doing data ingress from new data sources where AVEVA perhaps doesn't have an adapter or doesn't have any sort of data collection supported technology, you can write your own custom data collection with incredible ease. And you can do so independent of operating system and programming language. All you need is something that can generate REST messages and define JSON. So allows you a very scalable way of creating new data collection, whether it's on the edge, whether you want to do traditional on-premises server-side deployments, or writing to the cloud. And again, of course, this works with PyServer, data services, and Edge Data Store. So developers have incredible flexibility to reuse their applications to write to the cloud, or to on-premises, or to the edge. Now, to talk about how it works at a very high level, if someone is using the OMF specification to write data to an AVEVA destination, there's a three-part workflow to using it to write in data. I want to talk about that right now. So first, in order to send data, similar to object-oriented programming, we define what we call a type. An OMF type that's similar to defining like a class in object-oriented programming, where you are informing your destination, say your Edge Data Store or your Connect Data Services, you're telling it what is the data you're going to be sending to it and what formats. So you're going to say, I'm sending you a value that's numeric, or I'm sending you a value that's string, or I'm sending you, say, something called temperature and something called pressure, which are both numeric. It basically informs the destination what data to expect, in what formats, and with what names. So essentially, you're defining your class. We call this sending an OMF type message. And we'll get into later what this can look like. Now, next you have to create an instance of this class. You have to say, all right, I want to create an instance of it. We call that creating an OMF container. So we're saying, okay, destination system, now that I've defined my type and I know what data types I'll send you and what their properties are, here, create an instance for me. And that lets it create new archive records to hold this. So first you say, okay, this is the type. This contains my configuration, like what data I'm sending you. These create my instances of it, like my streams. And then now to populate those streams or tags with data, then you finally do step 3. OMF defines how you can send data messages, how you should structure those messages. And if you do, then it'll send data messages to those container IDs, like to those streams, and it'll properly update them with real values. So again, if you're creating an application or creating a data flow that uses the open message format, this is the workflow you will do. You'll send a type, you'll send containers to create instances of that type, and then you'll send data messages to actually send data values to those containers. And the OMF specification describes exactly how you should structure each of these messages, how you should send your types, how you should containers, and all of those. Now, let's get into this in a little bit more detail just to show you an example. So here you can say, I'm sending first my type. Now, this is a dynamic type. There's other types of types that we can get into the documentation. But basically, we'll say, okay, we're sending a dynamic type. I'm going to call my type, or maybe my class name, single value type 1. It's dynamic, so I'll be sending real-time updating values. So store these in streams or PyPoints. I've got a timestamp, which is a date-time formatted string, and it's the index. It's worth noting that OMF messages can define data types that have multiple indexes. Say for manufacturing, it could be your position on the manufacturing line, or for oil and gas, it could be your horizontal or vertical depth when you're drilling. So you can have multiple indices, and the point of having that complex data is it allows you much more freedom when you're slicing or dicing your data and doing your analytics. So you can actually have multiple indexes. In this case, we have one called timestamp, and we're sending a value. So this is a very simple type, something that's very easy to trend, very easy to work with. We're just sending things called, single value type 1, and they're all going to have a timestamp and a value. But now we need to create instances of this. So in our second container message, we send a message that says, okay, what's going to be my ID of this container, which would be the name of your PyPoint or the name of your stream in the Edge Data Store or Connect Data Services. So I'll create a stream or a tag named tag alpha and tag beta. What's the type ID? And this type ID is going to tell my destination, is it going to have a timestamp? Is it going to have a value? And so now my destination knows, perfect. These are the instances, the containers, and I know what they're going to be formatted as because I already have that type. Then finally, you can send some nice streamlined data messages. You pass in the container ID, and you say values, and it's an array. So you can actually do bulk value updates. And in this case, I'm just sending one with a timestamp. So my timestamp in ISO format and my value. I do the same thing with tag alpha and tag beta. So this is how easy it is to construct OMF messages. If I actually sent these messages along, it would actually be accepted by my destination. Now, the specification also describes message headers that also need to be set as well. And we'll get into what that is because we need to inform our destination that yes, we are sending a type message here and that we are sending a container message here and we are sending a data message here. And there are ways of doing that through setting message headers. And let's actually show you an example of this that's barely 40 lines of Python code. And this includes all the things. If you actually run this against an Edge data store, it will absolutely work. So what we're doing is we're saying, okay, let's import our requests library because we'll be sending HTTP requests. We'll be sending, JSON requests, but this can be done in Python, PowerShell, C#, Rust, what have you. We're going to be sending along a date. So we'll use a datetime library. I'm just going to be generating some random data. So I'll use random and I'll use time because I'm going to want to use time.sleep to loop. So for OMF, I have to first specify what's my destination endpoint. In this case, I'm writing to an Edge data store, but here I could write to a Pi server or to Connect Data Services. Now, if I was writing to those, I would also have to insert right here authentication code to sign in. In my case, I'm just writing to a local Edge data store. So I can skip that piece. Edge data store, if I'm writing through localhost, I can just natively write to this API endpoint. And now here you'll see the message of OMF headers. So in addition to sending those bodies, my type right here, my container message, and my data message, I also have to send headers too. And the headers informs my destination of what action I'm doing and what type of message. So here I'm saying, okay, create. My message format is JSON, my OMF version is 1.0, and I'm saying my message type, I set this to be, this is a type message, this is a container message, and this is a data message. So when you're writing OMF, not only do you define the body, but when you're posting that to your destination, you absolutely also have to properly set the message type. So just to go through this, remember, we're first doing our type, then our container, then our data. I'm going to find a type that's called sensor dynamic type 1. Its classification is dynamic. I'm sending just my timestamp and value. We saw this earlier. I set my headers to say, okay, this is going to be a type message. And then I just do a REST post to my destination. I pass in those headers and I pass in that body. And this tells my destination, okay, got it. I'm going to be receiving data of this type. Next, I say, okay, let me make my container JSON. I'll create one container here called sensor 74656 container 1. That's going to be the name of my tag or the name of my stream that gets created. And for the type ID, I'll say, okay, match the type ID right here. So that's what this line's doing. It's saying, okay, match that type ID. And then since I'm now sending a container message, because I'm creating an instance of that type, I set my message type header to be container, and I repeat that same post. I say, okay, write to my destination, pass in my new updated headers that now says container is my message type, and send in the JSON to create these containers. And now that's done, I've created a type, I've created instances of that type as a container. Now I finally set my message type to data, and I start sending data. I say, okay, my new data JSON is, here's my container ID, and I make sure this container ID matches right up here. I say, okay, let me generate a new timestamp using the datetime library. We generate a new bit of data. This is random, but this could actually be connecting to a new web service or a new data source if I wanted to, and finally do a request.post, same URL, updated headers that now have the data type as data, and pass in my new data JSON, and then sleep so that I can loop through that step over and over again. This is an OMF application. This will natively create data within an edge data store. You can add authentication to this, redirect this against a Pi server or against Connect Data Services, and it'll write to those as well. And speaking of how you would actually do that, there's some great examples in documentation. Now, what about this piece right here? Well, something about how Edge Data Store and adapters write to the cloud. Let me go back here and let me get into these a little more detail. Well, let's pick our MQTT adapter right here. Now, the way these work, when you want to set one of these up to point to Connect Data Services, you generate something called a client credentials client, which gives you a secure ID and secret that you include in the configuration file to let it, authenticate to Connect Data Services. And that lets it authenticate. However, that simply lets it connect to the cloud and, start writing data, and, actually be able to securely sign in. But that doesn't necessarily tell the adapter, where should I put this data? Remember I mentioned this thing called namespaces here in the top right? How they're all logically separated, like sequential data stores and other resources and assets? Well, it's very common that folks would say, well, I want this adapter to right here, this adapter to right here. I want everything that connects with this set of credentials to right to this area, everything that connects with this set of credentials to right to this area. Giving folks that freedom of storing their data in those specific namespace regions. And so it's not just creating the client credentials and creating the secret, which we'll get into later. You also have to specifically map, everything that connects with this set of credentials, I want it to write here. And you can make however many of those clients you have to get huge control over which is writing where. And I mention all this because that's what's done here in OMF Connections. So OMF Connections is used by Edge Data Store, adapters, anything else that's using OMF. And you can see what I've done is I said, for data coming from site 512, I've got a couple different clients, my IMP IoT modules, my Edge Data Stores and adapters. I've got this group for AWC24, for 78749 group. I want anything that connects with these clients to be able to write to a specific namespace. And so, again, very important here. If I don't do this, sure, my adapters and Edge Data Store authenticate, but the data doesn't know where to go. It doesn't know which namespace to get routed into. So that's what you do right here. When you're setting up data collection, you hit Add OMF Connection, and you can start, writing these into specific namespaces. And so I've mapped specific clients in. If you want to troubleshoot and make sure that your messages are correct, within Connect Data Services under the Developer Tools OMF Editor, we provide a validator for letting you make sure your messages are in the proper format. So you can say, okay, is my type message, do I have all of the right properties, all the right keys? You can paste it in here, and if, for instance, I have a typo or I have mistakes here, it'll say, oh, invalid OMF. You actually should probably change this back to properties format. Got it. It says, yep, now you're valid. Or if I say, I want to see how my container message should look. Maybe I forget that I need a type ID. It's going to say, oh, you've got invalid OMF. You should always include a type when you're creating a container. You should create an instance of a specific type by ID. And then if you're creating data messages, same thing. You can paste your data messages in here and it'll validate those for you. Incredibly helpful. We also, on GitHub, if you go to the github.com/AVEVA site, we walk through examples here that talk through how to use OMF in Python and C++, how to do complex data, do bulk uploads, show examples of how to work with some real sensors. This would be great getting started for folks if they want to look at an example application that we've already written and see how it works. And then finally, there's the documentation. The documentation gets into much more detail about the open message format and how specifically you construct those messages. There's a great section about the message headers that talks about what specifically you need to provide. Message type, format, OMS version, action, compression as well. You'll note that message type was the one that we are changing to be type, container, or data earlier. It also talks about the different message types, such as type, container, and data messages as well. And it gets through examples of how specifically you can define your type messages. What are the different keywords that you use for a container message? The same thing. What are the keywords? And for data messages. So if you want to expand on the examples here, highly recommend go through the documentation and noting, okay, for those three message types, your type message, your container message, and your data message, those three types, type, container, data, it goes through both examples and what keywords that you should use. But again, if you ever want to double check that, you can just paste your messages here, take a copy of them, print out or export them and validate them to make sure that your data, container, and type messages are valid. So Connect Data Services provides some incredible help here. You can mouse over to see more information about these individual keys and properties. Makes it really, really helpful for when you're working here. A final note about OMF. If we go back to our presentation, a question about security. When working with an open message format, it is the endpoint that defines the protocol and security for OMF messages. So specifically, if you're writing to Connect Data Services or a Pi server, you're doing HTTPS with TLS encryption. So you're using a specific header value. You're using, say, maybe base against the Pi server. You're using bearer against Connect Data Services. In case you're saying, hey, how do I define authentication? Again, that's not handled like within OMF. That's between your application and the endpoint. So it very nicely decouples that from the code that you have to write. So just a quick clarification point. Again, this is a point that's mentioned in the documentation as well, getting into how specifically that can work. But we absolutely look forward to hearing folks' thoughts on how they can use the open message format themselves. And granted, a quick recap, Connect Data Services gives you a great validator. There's some excellent documentation and examples of what data messages, type messages, and container messages can look like. And on our GitHub page, we have examples that you can go through on your own to learn more and see working examples that you can tailor for your own use cases. Again, altogether, the role of the open message format is that when you have new data sources, new applications, new data that you want to natively write to Connect Data Services, to a Pi server, to Edge Data Store, you want the data to be treated just like native data coming from other AVEVA software, you can absolutely use the open message format and will allow you to write that in the cleanest, most straightforward way possible. It will automatically create types, it will automatically create the Pi points and the streams on your destination, so you don't need to create those yourself. It's a very quick way of having lightweight applications write directly to these AVEVA destinations. And of course, if you have questions through working with the samples or going through our documentation and want to reach out to us, please reach out and look forward to seeing how you can make the open message format work for you. Thank you.